Welcome to IPC. I've missed you guys. I hope you enjoyed the previous video where you learned about what a mole is. Surely you've learned it because he talks about it for so long and uses his hands. And we know, and you know now, 1 mole is 602 hexillion of something, right? Of anything. And this, in the case of chemistry, let's say 1 mole of oxygen atoms is 602 hexillion oxygen atoms, right? I think we've already got that. Let's walk down memory lane for a minute. Let's talk about an oxygen atom. Let's talk about an atom. An atom is made up of protons, neutrons, and electrons, right? And we have learned in chapter 16 that a proton is 6.6726 times 10 to the negative 24th grams. It's so tiny. It's a really tiny measurement. A neutron is about the same. An electron is even tinier. Compared to these, it's practically massless. But there's a tiny bit of mass. And as we learned in chapter 16, these numbers are so tiny, it's hard to do anything with them. And so chemists have come up, well, for example, if we were going to determine the mass of an oxygen atom, of 1 oxygen atom, we'd have to take the mass of 8 protons. So we would do 8 times this tiny little number, plus the mass of 8 neutrons, which is this tiny number, plus this 8 electrons times this tiny number. And that would be a lot of math. That'd be a lot of multiplications with all these negative, or 10 times 10 to the negative, or 1 times 10 to the negative 24 grams. It's a tiny numbers, and they're going to be very complicated. So scientists said, forget that. We're just going to come up with a term called the atomic mass unit. And we're going to say every proton is 1 atomic mass unit. Every neutron is 1 atomic mass unit, or AMU. And 1 electron, comparatively, is essentially 0, essentially massless, because it's so tiny. It's actually 1 over 1,600. 1,1600. It's 1 over 1,600 of this mass. So it's essentially 0. So in our discussions in chapter 16, we would say the mass of an oxygen atom is 16 AMU. And we learned on the periodic table of elements, PTE, that this little number here, and I've actually created some little small pictures here, or I've created some blown up squares. Instead of looking at sodium here, I'm taking this and I'm going to bring it forward so you can see this blown up. You can see it a little better, hopefully. We know that this is the atomic number. It's the number of protons for sodium. And this, we said, is the average atomic mass. We gathered up in this case, we gathered up all the sodium atoms, or a whole bunch of them, and we determined the mass of each one, and we took the average of all that were out there. And on average, the mass of sodium is 22.990 AMU. Hopefully this is a review and you still remember all this. If not, go back to chapter 16 and reread some of this. As you can guess though, in chemistry, we don't measure mass in AMU. Since the beginning of this class, we've been using this little guy right here to measure mass, right? Hopefully you remember the name of this little guy that measures mass, and hopefully you remember the SI unit for mass. This is a balance, electronic balance, and we measure mass in grams. The SI unit for mass is actually kilograms, but in here we're using this balance measures in grams. So let's remember this here. In chemistry, we don't measure in AMU. We measure in grams. So we got to figure out how we can measure things in the lab that can take the atoms into consideration and how they can, we can't count the atoms. We can count grams and kilograms. So how do those match up? The mole is how we're going to do that. We measure mass of a substance in grams. And we've already identified that the protons, the neutrons, the electrons are in grams. We know the measurement in grams, it's just too tiny. So we're going to use the mole. The mole is 602 hexillion of something. And the abbreviation for mole, I don't know if you've learned this or not, the abbreviation for mole is MOL. So let's talk briefly about something you learned in the last video. We talked about, well, maybe they didn't talk about this, but if you say I need a couple of beakers, I would say I would need, if I said, hey, bring me a couple of beakers, hopefully you bring me 2 beakers, right? If I ask you to bring me a dozen beakers, you bring me 12. If I ask you to bring me a mole of beakers, you bring me 102 hexillion of those, right? Well, let's talk about the mass of these things. I have some black-eyed peas that I found in the prep room. If we all get hungry enough with the coronavirus, we can come raid the prep room and get some black-eyed peas to cook. If I wanted to measure the mass of a couple of black-eyed peas, I would put it on this little balance here. And obviously I wouldn't hold it in the air like this, I'd put it on a flat surface. But I would put it on my balance and it would give me the reading in grams. I've done that already, and it is a couple of beans, or 2 beans, is 0.52 grams. If I measured a dozen black-eyed peas, if I wanted to measure the mass of a dozen black-eyed peas, I would put it on this balance, and it would give me a reading. And I did that already beforehand, and it is 2.85 grams. Now, if I took a mole, which is 602 hexillion beans, if I took a mole of beans and put it on my balance, as you can guess, this is not 602 hexillion, but let's pretend like I have a mole of black-eyed peas, and I'm putting it on my balance that can measure to that capacity, I would get a reading. And let's pretend like that reading, let's pretend like I should have a reading, and let's pretend it's 24 bazillion grams. This measurement is called molar mass. Molar mass. The mass, in this case, of a mole of beans is this number, 24 bazillion grams, and that's called the molar mass. If I took, let's say, a mole of oxygen atoms, I took a mole of oxygen atoms, 602 hexillion oxygen atoms. If I took a mole, which is 602 hexillion of oxygen atoms, and I put them on a balance like this, it would give me a reading. And that reading would be 15.999 grams, and that would be molar mass of oxygen atoms. This number right here might look familiar to you. 1 second. I am taking from the periodic table of elements oxygen, and I've blown it up right here for you. And looky here, oxygen, 15.99999. The molar mass of oxygen is 15.9999. So on the periodic table of elements, everybody lean in and listen because this is important. On the periodic table of elements, this number here, which we've been calling average atomic mass, which it still is, average atomic mass in AMU, it's also the molar mass of the element. If I got 1 mole of oxygen atoms, 602 hexillion, and I measured the mass of them on a balance, it would come up at 15.999 grams. If I took a mole of potassium elements, put them on that balance, and measured them, it'd be 39.098, which is what's on the periodic table of elements. This is the molar mass of the element, the molar mass in grams of the element. And down here it says the molar mass is the mass in grams of 1 mole of a substance. And in chemistry, we're going to be talking about elements and also compounds. All right. 1 second. So how is this helpful? How is it helpful to know that, 1 mole of sodium equals this in grams? It's very helpful. We're going to work some problems. And before we work some problems, we're going to create some ratios. We're going to create some ways to convert between moles and grams. You can see this. I think you can see it from there. 15.999 grams. Where's my marker? There are 15.999 grams in 1 mole of oxygen. Those numbers equal each other. So because they equal each other, we can create a ratio. We can say there's 15.999 grams in 1 mole of oxygen, or we can flip it. We can say in 1 mole of oxygen, we have 15.999 grams. We can say we can make the relationship either way. We can say 15.999 grams equals 1 mole, or we can say in 1 mole, there's 15.999 grams. So it's important that you can take an element in the periodic table like this, and from here, create a ratio. Let's do one with calcium. With calcium, we would say the ratio I would use, or would create from this, I would say in 1 mole, that's terrible, in 1 mole of calcium is 40.078 grams. Or I could reverse it. I could say 40.078 grams calcium equals 1 mole. So you see, from this, we can use either ratio, and we're going to use that in some problems. Actually, let's talk about one more thing. We've talked about elements. We talked about elements like oxygen or hydrogen or mercury. But let's talk about a compound. If we wanted to know how many grams are in a mole, in this case of nitrogen dioxide, we can't find nitrogen dioxide on the periodic table, right? It's a compound, or actually it's a molecule. But we can find nitrogen. If you'll give me a second, I will find it. We can find nitrogen. We know how many grams are in 1 mole of nitrogen, and we know how many grams are in 1 mole of oxygen. So with that information, we can figure out the number of grams in 1 mole of nitrogen dioxide. So if you have nitrogen dioxide here, we know in nitrogen dioxide there's one atom of nitrogen, 14.007, and there's 2 oxygen. It would be Actually, we're just going to round to the ones place going forward. So we're just gonna say that's 14 grams. And we're gonna say this 15.99999 rounds to 16. 16. If I add these up, I will get 46 grams. So in 1 mole of nitrogen dioxide, it would have the mass of 46 grams.